about is if you're thinking from a DNS perspective, and just for folks that don't really understand the way DNS works, is first you've got a client device, and that goes to a recursive server. That recursive server then has to say, all right, so you're trying to go to www.google.com. Where do I take you now? And it goes to a root server and acts on that behalf. Now, it's that first DNS server, that recursive DNS server that's doing the hops there. Essentially, how does DNS over HTTPS actually change that?
You hit a very important point. So DNS over HTTPS actually goes to that recursive server. So imagine on one end of the string, there is a browser running in a computer on an end user's laptop or a computer, connecting to that well-published DNS over HTTPS server, which is a recursive server. Up to that point, the entire communication is encrypted, right?
Yeah.
And what happens behind the scene is dependent on implementation. So the reason I think that's really important point is because the authoritative root naming server, which ultimately does the lookup and says, hey, www.google.com is this IP address. That bit of record lookup is not guaranteed in the sense that there is no authenticity to confirm using this protocol that this is indeed an authoritative answer, right? That's number one.
Yeah.
But number two, the communication between the recursive server to that root server is also implementation dependent. DNS is such an old protocol, goes back to the dawn of the internet, and therefore these things were probably not baked into it from design perspective. The only authoritative response you could hope for is using a protocol called DNS SAC, which is where a record if the record is not authentic or authoritative and it's not authentic, the end user browser has using certain tools, you can actually determine that it is indeed not authentic lookup. It doesn't stop the fiddle in the middle, so to speak, but at least that comes across to the end user. DoH solves the one piece of puzzle, which is where the threat is prevented from someone who is sniffing the wire between the recursive DNS lookup server and the end user's browser. That is the bit which we are protecting. So it doesn't solve the whole security story.
Okay, but I think part of it, and I know DNS is an important part of providing an authentication of like who you're connecting to. DNS over HTTPS is a little bit different. It's really talking about encrypting that DNS traffic. It's talking about who's actually looking up and providing that answer. Because in my view, a browser client in a normal world is going to have to go to a recursive server to then go out and start figuring out like what's the IP address of this this web domain. It then by implementing DNS over HTTPS, to my understanding, correct me if I'm wrong, but you actually change that. That then goes to where the browser is setting to go. If it's Mozilla setting it, then it's going to go to Mozilla. We're hearing rumbling about Google going to be adding this into Chrome. If they do that, then it's going to go to them or whoever they set as the resolver. Right now, to my understanding, it's normally like the ISP that's providing that recursive DNS, that's doing that recursion and providing that answer back. What do you think of this? Do you think is this a good thing coming out? Like what happens? What do we not know?
we actually, the correct answer is, I guess, we just don't know enough just yet. The reason is that in a traditional model where a browser simply looks up the DNS in clear, traditionally the way it's been happening, ISP would stand up their recursive server. ISP can monetize this service, as you would imagine. And they could then go to one of the several root naming servers on the internet. And in some ways, there is a clear advantage to doing that because your DNS lookup is not centralized. It is truly decentralized, right? And at the point where ISP decides to handpick the naming servers they wish to use, they have some control over that. So if you were looking at this issue from data collection perspective, where a, a nation state wants to control their ISP, they have power to do so at this point, right? Because that's their entry into having a
Yeah.
sneak peek into what users' activities are. The
And
other side, right? And when you talk to DoH, that disappears. So in a way, yes, you're
well,
now able to pierce through Great Wall of China, but the one thing you will end up with is centralized DNS lookup. So one or probably a few service providers having a greater control on what users go to, who do they, where do they get redirected, etc. How the traffic is routed.
that's a great point, and I think it's important to point out that it's not just maybe a nation state like China or something like that that's really ruling with an iron fist. It's normal ISPs do some sort of censorship anyway, and by and large, I think that's probably a good thing of ISPs.
Indeed.
Filtering out things that are grotesque on the internet, things that you want to see, child pornography,
Absolutely.
all kinds of horrible things, right? But then, so it's good to keep an ISP in the loop with that regard. Essentially, DNS over HTTPS cuts them out. To my understanding, it then filters that to essential places we're discussing. And it might help something like traffic going through China and trying to get through that Great Wall of China, so that it goes to a source that we might trust a little bit more. But I wonder if that actually solves really anything.
It does and it doesn't, depending on your you look at the end user's perspective, right? I think that these are really important points which Mozilla's move doesn't really resolve. Neither does it Google Chrome's update number 78 will. The difference though is that Mozilla is going to lock their browser down to Cloudflare, whereas Google is keeping DoH configuration, resolver configurations much wider. So that there are still only a handful though, right? Let's not get excited, right? It's just half a dozen or so. But
yeah,
if you were to look at this whole issue of users being closely monitored on where they are going, where are they pointing the browsers to, I think it matters less so in our part of the world and then probably a lot more in part of a world where nation states are controlling users' access to internet generally, freedom of access to information, etc. This is where it does become very relevant. Although, like I said, it doesn't solve the entire equation of confidentiality, integrity, and availability. It only solves the confidentiality piece of the triage, right? So it is really not going to solve all the issues just yet.
I think it's a great idea, but I don't think it's a silver bullet. I don't think it solves all the problems
Absolutely not.
that we have right now. I think DNS is too complex.
Absolutely true. And even if you look at it at the enterprise level, the whole enterprise might have a certain security policy. And if browser as widespread as Chrome and Mozilla are wired with DoH pre-configuration, they simply lose sight of employees' access from enterprise network to the outer internet out there. And that can itself be a problem. However, in case of enterprise, this is much more controllable, right? Because the rollout of the browsers to employees' computer can be highly controlled, whereas rollout of a browser generally to public for public consumption is not. And this is why it becomes a very interesting challenge, since it doesn't solve all the problems, especially around authenticity of the lookup record on DNS. So this is why I think this is just a beginning in the movement of addressing the security and privacy.